Greetings. Welcome to a video I'm recording that is documenting the process of me going through and creating a game engine, I guess. And I'm saying that with some trepidation. My current plans are to create a game engine written in Rust that I will then create bindings to in Python. So what I want to do is make a game using a game engine that I wrote. I'm not sure how much of the engine I'm going to whole cloth write, though. That's the thing. So I'm kind of wavering between writing a lot of the game engine or utilizing existing game engines and then kind of composing a more useful game engine from an existing game engine library, I guess. So I guess what I mean by that is, like, especially since I'm using Rust. So Rust has some game engines or libraries, depending on how you look at them. There's two real options in Rust right now, and I want to, and I kind of want to make my game in Python. So, and there's also maybe 2 or 3 real options in Python too. So the options in Rust are the Pyston library and the Amethyst game engine, which is not really stabilized right now. It's awesome. I like the look of it a lot, actually, which is part of the reason why I'm wavering on making decisions currently. So I might try to make things agnostic to the underlying engine that I might utilize, so that I could plug it into Amethyst or Pyston. But in the Python, you have Pygame and maybe 1 or 2 others, and you have Piglet, and then which is kind of like a Python wrapper in STL, which is a C library. Very lower level. You don't really. That's what you would use if you were writing your own engine whole cloth, which I don't want to do. So my current plan is just to make like an engine that is kind of just a wrapper around another existing engine, but has a lot more boilerplate removed. So it'd be like an engine that could be used to quickly create something useful. So it's like a lot of helper libraries and things. So on some level, it would really just be like a flavor or like a skin on an existing engine on some level. And those things kind of exist for like a lot of other. You'll see these in a lot of open source projects where they'll be like, for example, for Java, they have there's like a game engine called LWJGL, and then there's another engine which is kind of like built on top of that engine called libgdx, I believe. And then there's another engine for that's like the bindings for libgdx, but in like one of the other JVM languages, for example. So I kind of want to do something like that a little bit, which is just to make something in Rust and also Python that is a version of a game of an engine that isn't too much, basically. So something that is lightweight, good for rapid prototyping, and easy to get into with low friction. And Rust doesn't have any of those right now. Rust has Pyston, which is not any of those things. It's amazing and fully featured and very complicated. So I want to make something that kind of cuts through the bullshit, basically, and just kind of gets you to making and doing the things that you want to be doing pretty quickly, basically. So I want to make something that's a lot like Love2D, essentially. And Python, admittedly, its game engines are like that, but they're not really well supported. They're old, and I don't know. I want to make my own thing. So I'm going to make it in Rust, and then we're going to create bindings to this engine in Python so that the games will actually be written in Python, and they'll call the Rust code instead. All right, so let's just get started. So here, because I've already been talking for 4 minutes, here we have I've created like the boilerplate for the code here. So I'm calling it Pyston. This is just a brief proof of concept demo of how I will go about doing this, or how I might go about doing this. So I'm just going to demonstrate creating the Rust code, calling it from Python, basically. So here we have some dependencies. We are getting, and we don't actually need specs. We're just using Pyston window, find folder for a texture a font asset we're using, and Pyo3, which is the Python um, magic that Rust will use to create the export the Python modules basically. So, all right. So, and then here I've kind of done some boilerplate as well, and I've kind of done some comments too. So I have it all set up, and then we're just gonna get right to it. So we've already gotten our crates kind of declared and imported. So what we want to do is we're just going to create a window. We're going to create the window in Rust, the Rust code using a Pyston window, and it's going to say the window is going to have some text in it, and the text that it says is going to be passed in from the Python code. So that's basically it. So I'm kind of meshing together two tutorials that I read, and I've kind of gone through the work of kind of taking these two tutorials and kind of doing things with them that are relevant to me, so to speak, that kind of do the things that I want to learn how to do and that you might be interested in learning how to do too. So if you're seeing some code that looks familiar from the tutorials from Pyston, for example, or from Pyo3, that's because I'm basically just, I took the tutorials from both and was like, what if I did in this tutorial, I did this tutorial inside this tutorial, basically. And so I'm just kind of combining, and when I say I'm doing these tutorials, I'm effectively doing them. I'm not literally repeating the tutorials. I'm just doing a lot of the same things that the tutorials cover, which is just opening a window and displaying text, So it's a very bog standard thing that you'll have to do at some point anyway. So, and the same with the Pyo3 thing, where I'm creating a class. So we're going to create a data type for our engine. This is my example. So this is just the proof of concept. My final working project isn't going to be called Pyston. So I'm just calling it Pyston because it's descriptive of what I'm doing in this demo right now, which is I'm using Pyston, Piston, and I'm calling it from Python. So with py, so it's Python Pyston. So anyway, my project will have a different name ultimately because I don't really like Pyston that much. I probably don't know if I conveyed that enough, but I'm not the biggest fan of it. It's a bit too complicated for my taste. I like things to be a bit more straightforward, and I don't know, Pyston has a lot of weird things going on with its structure because they like to have like all these crates that are independent of each other, which you end up getting this really bizarre structure that you have to figure out, and you're never clear where the fuck where the thing you want comes from necessarily, and it's complicated, I guess, more than anything. It's just a bit much for new beginners. I'm sure it makes sense once you learn it all, but it's a bit much to start with, I guess. So we're going to create a data type. What we want to do is we want to create a class in Python for our Pyston window or our Pyston engine, for example. So here we're creating a data type in Rust called a struct, and we're annotating it. We're giving it this. We're using this macro here to define it as a Python class, and this is going to do some magic behind the scenes and kind of create the Python bindings for this struct to make it a class, basically. And then we're going to have structs in Rust or struct definitions are pretty straightforward. You can think of them as basically just you're describing the data structure of a type. So you don't really define any implementations of methods in a struct definition. You just basically describe the data that it contains. So it's going to contain a window, a Python window, or a Pyston window. And then it's also going to have some text that it will display to. Or actually, I'm going to change things up a bit. And we're going to make it just contain a window for now. And then, and I can probably remove this while I'm at it. Okay. So we got that. Now we are going to do implement our methods. So in Rust, you implement methods for a type if you want them to have methods. So you do it. So you just say implement your type, and then you decorate it with methods. You say I want it to have a debug thing or something. You can actually derive a lot of methods for types in Rust, but we're not going to do that right now. So this macro associates the implementation of this type with the methods for the class. And Py03 has your methods need to have a certain type signature for them to be proper Python methods. So I'll tell you about. So you're going to make a function. So first of all, if you want to be able to have the Python code initialize an instance, to have initializer functions, then you need to create what's called this new function here, which is going to operate effectively as the init function in Python. And then we're just going to pass in a data type called a PyRaw object, which we can look at what this is from Visual Studio Code, but used to create objects in Python. So, and then that's it. That's all we're going to have right there. And then we're going to have a Py result. It's going to return a, which is, so all methods that belong to your Python object must return a Py result. And even if it ends up being nil, which is what these empty parentheses is going to describe. So this is going to be a function, which is interesting because, and the reason why that's the case is because this object is actually, the constructor is actually going to set the return of the object in this reference to this PyRaw object instead, if that makes sense. So kind of like how your constructor doesn't actually have a return in Python. At least I suspect that's what's going on here. Otherwise, I don't understand why we wouldn't make this our Pyston type, but we're not doing that. So this is, again, their tutorial, and as far as I can tell, this is what you want to do based off of their documentation. You want to init your data type inside of a closure here. And we're just going to have a 0arg closure. And it's going to be called Pyston, yes. And it's just going to have the window. And we are just going to create the window now. Windows, and this is like a window factory method, just like so. Yeah, so it looks good. And then we're going to give it a name. The window, we're going to call it Pyston window. And then you give it a vector with the dimensions that you want for the window. We're going to make it 800 by 800 because why not? And then we'll just do that. And then this is a Fluent interface for this window builder. We can say we want it to do exit on escape. So we're just kind of, this is what the tutorial does. So this is one way to, you're just kind of like adding on, this is a way of kind of detailing the settings for the window without having to do this, configure the settings with like some weird data structure that you pass into the constructor. Instead, you just kind of keep on decorating it with the builder with like the settings that you want, which is a better way to handle it than passing all them in as parameters to a single method, which is kind of unwieldy and ugly looking. Okay, cool. So this looks good. Or does it? Object init. We build it. Exit on escape. And we unwrap. And, sorry. And we need one very important detail we need is the macro new. Was that really complaining about this though? Okay, I was going to say that shouldn't be complaining about that. Okay, so here we've defined the constructor by having a function with a specific name and this new macro. So this is going to be the constructor that is used to initialize the type that you can call. So you can call this constructor from the Python code, just the way you would any other constructor. And then we want to create a function called run, and we're going to have it pass in the text as a string, just like so. Actually, this type of string, which is something specific in Rust. Okay, and this will return a... Oh, I'm forgetting. We want this function to operate on immutable reference to the self. It's going to accept a Python context, and then that all looks good to me. Py result. Okay, and so far so good. It's not complaining. And now what we want to do is, and I'm trying to think how much busy work I want to avoid here. I don't want to have to type this all myself, so I'm going to copy and paste in some code that involves loading a font resource. So here is some code that I may have written earlier, and what this involves is this loads a folder, and we use this library, this Rust library called findFolder, which does you can think of it as doing like a search for a folder with a specific name, and you're specifying how many parent folders to search up from and child folders to search down from for this assets folder. And so relative to where we're located at, it's going to try to find this assets folder, and we're specifying basically a range of depths in the search tree to look. And so that gets that. We debug it like that. I'm just going to read the debugging information. And then we're going to say we want to extract this font from the assets folder that we may have found. So this takes the path here and adds on this resource that we want. And this join just kind of loads that resource, or actually just kind of really just kind of gets you the file to it. And then here's where you actually get it. You initialize the glyphs for the font with giving it the file path, I believe. Please help me here. Well, anyway, so you have your window. You give like a window context, the path to the font resource, and then some texture settings. This is all really obnoxious Pyston stuff that I would like to abstract away. This is exactly why I want to make my own engine, because I think Pyston is unwieldy, difficult to use. It's like you look at this and it doesn't exactly seem very intuitive. So I would like to just make my own library that's easier to parse out and figure out. Ideally it'll kind of make it so that you don't have to think about a lot of stuff. It'll just have a more opinionated approach to the stuff, maybe, perhaps, or maybe not. Maybe it'll be just as robust, but it just won't be as obnoxious to use. That would be ideal, but that's also pretty grand. So the scope of my project is going to have all the functionality of Pyston, because that's just, no, one person can't do that. I just want to be able to make the game that I want to make and make it in a way where I'm sane. So that's my goal. So cool. So now we've gotten our font here, our glyphs right here. We should go ahead and get our window. Boom. All right, so this window next function, what what it's effectively doing is like it's basically like the next update to the window. You have a closure that you can you have this this is an event, like the next update. This E is like an event. And you're just saying, so self in this context is the piston type that we created, and we're accessing the window that belongs to piston. And we're saying draw 2D, passing a reference to the generic event as that's my impression of what that is. A closure here containing some type of context and graphics, some window context and a graphics context perhaps. I'm not 100% positive. Generic event fn once containing a context and a g2d, graphics 2d context. See, I'm not positive what that is. I feel pretty confident thinking that this is like a window context and this is like a graphics context, but I'm not sure if the distinction is meaningful. Cool. So now from within here, we want to get a apply transformation or build a transformation. And this transformation is going to be a translation, this is one other thing I don't love about Pyston 2D. Granted, this might be another coming from another library that Pyston uses, so this might not be Pyston's fault, but we're going to translate the text. We're going to move it to the center, maybe, of the display. So we have an 800 by 800 window, I believe. I can make that a const dim of type usize equals 800, I believe. That is. Cool. Half type usize equals dim over 2. Okay. And so what we're going to do is remove it to half. Oops. F64. Is that what? Yeah. Let's do that. Because maybe that'll work. Cool. And then we are going to clear the window, which basically sets it to we're setting the background to a color, and this is going to be a vector that I think this is black, so this is like the RGBA, and I think this might be the color depth, that 32 there. Oh wait, that's going to be the graphics context. And then, sorry, I was looking ahead at my code here. We are going to, this text right here you're seeing is actually not, is a module, not from the local text here. So we'll call this T. Window text. New color. Pass another vector. So this is the font. This is the text that we're rendering the color of the text. 0.0. So 0. So this is a green text probably. And I'm imagining that's like the font size. And then we're going to draw this text. and then this is going to return some result type that we're just going to unwrap. So what we're drawing now is the window text, and passing in a mutable reference to our glyphs here. Context, the draw state for the context, I'm assuming. Our transformation that we're applying, which is in this particular case is a translation. Transform here. Okay, so we're getting some complaints here. That's fine. We'll find out. That's fine. Okay, so this will be U32. All right. Don't know why that can't be made a U size, but that makes sense. That'd be U32 over U size. U size is a type that would probably be better for like array accessing arrays, that positive indices, if that makes sense. So it's like a sized type as opposed to a generalized unsized integer. But to me, I feel like they should be interchangeable still, but whatever. That's okay. There's probably a good reason for that. Cool. So this is looking pretty good. Okay, so let's just take a second to look at what we got here. We have a struct, a Rust struct called Pyston with this macro that makes it that defines it as a Python class, and this is going to do some magic to kind of prep it for being exported to a Python module as a data type that can be used from Python. And then here we're defining methods, Python methods for our Python data type, and then our methods have to abide a certain function signature. So if I didn't do this, for example, and then I removed that, I think this would complain because it needs to have all the functions become a Python result. So again, the convention, or not the convention really, but rather the invariant for all the methods that belong into their Python methods is that they must return a Py result. And additionally, they must also have a Python context in the function as well. I believe the first parameter will implicitly be, if it's a function that operates on the instance, will be the self, but then the second parameter, of course, must be the Python context. And then the parameters for your function may then follow. So in this case, the text that we want to display on the window. Cool. So here we've defined this Python class and its methods. Now let's go ahead and define the module. And that's pretty straightforward. We just kind of have another macro for that. PyMod init. And then we create a function that I believe must have the name of the module that we expect to have, and it must match the lib module name as well. So our Python context, and then a Python module. So you can think of this as being like a function that accepts a module that we're going to decorate with whatever functions that we wish to export, or data types, or any values as well. So this is how we build the module, and this function kind of receives, this function will be invoked and receives the module that we're going to build or append to. Py result, boop 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 boop. So we got that. And similarly to all other Python methods, this must return a Py result. So now let's use this module, and let's just add the class that we are creating using this add class method, which really just contains the type of the class that we want in there. And that's basically it. Boop. sorry. Say what? That's right. Okay, so sorry. This returns a result type, and we are just going to handle it just by saying, if there's an error, whatever. If there's a value, that's great too. So this question mark basically just kind of implicitly unwraps the result and deals with it. So I could say that. So the signature of that question mark basically means that let a equals that the value of this a is going to be whatever the actual possible result from this function is, not the result itself. So this function returns a result type. And if you want and a result is kind of like an algebraic data type that may possibly contain a value or an error, basically. If you just want to deal with the possibility of it, if you only want the result, though, you would add this question mark there, and it kind of it's a way of kind of hand waving away a lot of that. Actually, that might not be true. So yeah, it's a newer Rust feature. So now that we have all of this, so in quick review, we've defined our class. We've defined methods on our class. So we're using our macros here to make sure that our Rust data type is associated with a Python class and the methods for that class. And these macros have certain expectations for the Rust code, namely that the methods have a certain structure to them, a certain type signature, and that they abide the signature of returning a Python result and accepting a Python context if they are regular old-fashioned Python functions, or if they're the initializer that they initialize using the Python raw object as the first parameter. And there's probably some additional facets here and there for more complex things that we may want to do later that we'll find out. But for now, for our basic proof of concept, this is looking pretty good. And then here we just kind of set up our module for export. So the module you can think of as being like when you're writing Python code and you're writing it in a file, like a .py file, that's really a module. You can think of it as being a module. So you can have multiple classes in a file. That file itself is treated like a module. So this is just us saying we're adding to a module. This is like us saying, here's what we want to include in that Python file, basically. And this looks pretty good. Okay, cool. So I'm going to, do I have a terminal? I don't know. Okay, sorry, I'm going to open up a terminal window over here. I'm going to remove this env. Okay, so we've gone through the work of writing all the Rust code, and it theoretically compiles. So let's try compiling it actually, just to make sure it actually works. So cargo build. Oh, we should make that happy. Let's do that. Yeah. Sure. Okay. Anyway. So if this were my first build, you'd see a bunch of stuff being downloaded and compiled. Thankfully, I've done this already. I've kind of prepped for this video, so you don't have to watch all that stuff, but just bear in mind that you may have to do that at some point. So this code here, this is a Rust code. We've gotten all the stuff ready to go. I've demoed that we can build it. So what we want to do is we want to export this to a Python module and then try calling this from Python code, basically. So we are just going to do that. So I'm using a library that I referred to over here in my comments as pyo3pack, which allows you to export to some type of Python module, which is like another, just like any Python module. You can put in your path and import it into your Python workspace or whatever. You can also export to PyPy, which is the Python dependency repository, and then you could import it using your dependency manager of choice in Python, or you can just have it installed to your Python environment. And so that's what we're going to elect to do in this particular case for debugging reasons. So like while we're working on this, that's the ideal choice. Until you're ready to go, you don't really want to export it probably, or install it to the repository. So that's what we're going to do. So here I'm going to make a virtual environment, Python. Actually, we should make the directory first. Make dir env. Then we're going to say Python 3 m venv into that env directory, which is going to create our virtual environment. And then we want to source that virtual environment we created, bin activate. And here this indicates that we are now inside of a Python virtual environment called env. So now that we are there, we can say pyo, what's that called again? Pyo3 pack. We're going to tell Pyo3 pack that we want to. You can look at their website. There's basically three flags for the way that you export a module. You can publish it, like I said, to PyPy or some other repository. You can build it to a module, but we're going to, like I said earlier, use the develop, not debug, the develop flag, which builds it to your, installs it to your virtual environment. So we're just going to do that. Pyo3 bindings, found Python 3.7 to Python, and boom. So nothing exploded, right? So it probably worked. Let's give that a shot. So Python 3 from Pyston, import Pyston. Okay, this is looking good so far. So from our module Pyston, we want to import the Pyston data type. So this is like our uppercase, this is our struct here that we're importing. So our module is the lowercase Pyston, and then to that module we added our class Pyston. So this is like, we're just saying grab that class from this module, we're binding that class to Pyston, or we're getting it as Pyston. So, and now we can create a new window, w equals Pyston, like so. And here you're seeing the window being created in a really ugly way. And we need to run it. So it looks strange because we kind of do this awkward thing where we build the window before we start rendering with it. That run function actually has it begin to render it. So when we do w.window.run, this is when the actual work happens. Jello, or goodbye, and I don't know. Thanks for all the don't panic. There we go. It's Hitchhiker's. Don't panic. Exclamation mark. And it's technically starting at the origin, but because of the offsetting of the text, it looks like it's offset from the center. So obviously, what I would probably want to do is divide from the center by the width of what I would expect the text to be, so it'd be centered. But whatever. Anyway, point is, it worked. So this is pretty magical. I think it's loading the font, probably, right? Let me me see. Am I seeing I guess I omitted that print statement for that resource. So I'm fairly certain it's using that font that I loaded. I could be wrong about that, but even if not, that's fine. No biggie. So yeah, this is pretty cool. So we're using a Pyston window to create a Pyston window so we're running Python code to create from Python we opened a window and then rendered the window with some text that we supplied. And let's hit escape here, which allows me to quit this supposedly. Granted, it does not appear to be actually closing because, keyboard interrupt. Oh, come on. Anyway, we'll close that. So, so just to demo that again, from Pyston, import Pyston, or let's just import Pyston this time, just to kind of demo some stuff. So now we can say w equals Pyston.Pyston. Thanks for all the fish. Boom. So this creates the window, and then we just say w.run again, and oops, we want the text. And I guess I passed in. Wait, I'm sorry. This needed the parameter, not the other one. Thanks for all the fish. Yeah. Sorry, I passed the parameter into the init function. So I actually called it wrong, but that's okay. So Python doesn't really care if you give something too many parameters necessarily. This might actually be somewhat revealing of the way that Pyo3 handles function parameters to methods, because it seems to me that they might all be kind of coerced to being variadic functions, which is kind of a weird way to handle it, but that's okay. Which is probably why I probably didn't complain about that. But so as you can see, we've demoed calling our Rust, the code that we wrote a program in Rust, compiled it, and exported it to something that can be run from Python. And it was pretty straightforward, as you saw. We didn't really need to compile it from Rust, actually. We actually had that, we had Pyo3? We had Pyo3 do the work of compiling it in Rust and then kind of creating the bindings for it. And then it just added it to our Python environment. And it was just as easy as saying Pyo3-pack develop in the cargo project, basically. And then it took care of the rest. So call this from within your cargo project. Again, you want to configure it in such a way that you have named your library. You've made the crate type a C dynamic library. And that you've maybe added these features for Pyo3. I'm not 100% positive that this is necessary, but I think it is. And what did I save here? Oh yeah, I don't want that. So yeah, it was pretty straightforward, I feel like. So this is laying the groundwork for a lot of the things I want to do and the ideas, but conceptually this is pretty cool, right? The ability to write code in Rust, compile it, and make it invocable and runnable from Python. And to me, this feels pretty ergonomic. Like, this is fairly easy to do with the Python side of things. I mean, that just decorating like a struct definition with this macro, piece of cake, right? And then similarly implementing that type with just adding these macros, and then having to make your functions kind of have a particular signature, so to speak, that kind of accepts certain Python, like a Python context, and returns a Python result type. Like that seems pretty sensible to me. And then having a Python module function kind of initializer, so to speak, is, to me, this makes sense. So this small amount of code, but we've managed to do a lot, and and so just this uses a Rust library, creates a window, and we've kind of added some text in there, and we've only written like 50 lines of code or so, and yeah, and then we've just very, very easily export it to a Python environment, or we could do it to a Python. We could just build it and make it something that could be shared or upload to an Artifactory of some type, some Python repository, if you will. So yeah, so stay tuned, I guess, for future updates as I do more interesting things with this project. So as I start to flesh out and build out the engine more, so that we can do more interesting things from the Python code than just that. Stay tuned. But yeah, if you're interested in the idea of kind of doing a project that interops between language environments, like being able to do this, I think is really, really awesome, and I'm somewhat excited about this. So thanks for watching. Hopefully I didn't scare any of you off, I guess. Yeah, so enjoy and stay tuned for any future video updates.